Hey guys, good afternoon and welcome to our subtracting negatives video. So you guys should have finished up your homework from today, from Wednesday. You should have finished up the last few questions where you were subtracting positive numbers. And now we're going to subtract negatives. So if you guys were wondering, why are you making me do all this? Why are you making me draw all these symbols and uh, and make all these extra zero pairs? What's that about? This is it. This is what I've been psyched about since I don't even know when. I mean, I've been thinking about this since at least March, just this day right here. And I hope you guys are as excited as I am. Can't even talk right. I'm so pumped for this. Okay. So we're going to show the number 4. We're going to show it with chips. I'm just going to use the pluses and minuses by showing 4 positives and 4 pairs of 0. So, like I told you guys, you could have 4, or you could represent that as, so this is 4, or I could have 4 plus 0, still 4, or 4 plus 0 is still 4. I could add another 0 and another 0. I could keep adding zeros forever, and it's not going to change the value. I still just have 4, because this is 0, and this is 0, and this is 0, and this is 0. And again, that's because, 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0. Anytime you've got those pairs that represent 0. So this is like saying 4 plus 0 plus 0 plus 0 plus 0. So you're going to want to strap down for this one. You want to take a seat, you want to buckle up, because it's about to blow your mind. So I'm starting with 4. I'll start with 4. And it says then take away. And what operation in math are we doing when we take something away? So what operation is represented usually by the words take away? Well, usually it's subtraction, right? So I'm taking something away, I'm subtracting something. Well, here we go. We started with 4, right? Started with 4. I'm taking away, and then it wants me to take away 3 of the negative chips. So 3 negatives. So this expression right here is saying start with 4 and then take away 3 negatives. So I'm starting with 4 chips, right? Here's my 4, or 4 plus 0 plus 0 plus 0 plus 0. I could make as many zeros as I want, but this is still 4 right here. That still represents 4. Okay, so 4, and I'm going to take away 3 negative chips. So we started with 4, and I am taking away 3 negatives. So when I take away 3 negatives, I'll show that one more time. When I take away 3 negatives, what am I left with? I've got 1, 2, 3, 4, 5, 6, 7 positives all by themselves. And then what is this? What does a pair like that represent? What number does that represent? Well, anytime I've got 1 minus 1, or plus 1 and minus 1, we know that's 0. So here I've got 7 positives and one pair of 0. So 7 plus 0 is 7. And many of your teachers might have said in the past, well, anytime you see a negative, anytime you see those two negative signs, well, why don't you just take the two negatives and make a positive? But at least when I was in your seats, I always wondered why. Like, I get it, I'll do it, great, but why? Why am I doing this? I wanted it to make a little bit more sense. So here, let's remind ourselves, we started with 4. So this is 0. All of these orange ones are 0. So we started with 4 positives. Just these 4. And then I said take away 3 negatives. So we started with 4 positives, and I said take away 3 negatives. Well, what happened? If I take away these 3 negatives, then what am I left with? I've got 1, 2, 3, 4, but also 5, 6, and 7. So now here I'm left with 7 plus 0, or just 7, which is just mind-blowing. So, I mean, what happened when we subtracted a negative? What happened there? Well, my number got bigger. I started with 4 and some pairs of 0. I started with 4, and when I subtracted negatives, I ended up with 7. Because I subtracted 3 negatives, and now I've got 7. So 4 minus negative 3 is 7. When I subtracted negatives, our number got bigger. Okay, so the big question then becomes, well, if I'm subtracting a negative number from any number, is that first number ever going to get bigger? Is it always going to get bigger? Will it ever get smaller? Well, let's try it with another quick example. So I'm going to do, let's see, 2, and then I'll have a couple pairs of 0. So I've got 2 right here. This is 2. So I'll start with 2, and I'm going to take away 1 negative. So 2, and this is taking away 1 negative. That's what this expression right here is saying. So if I take away one of these negatives, then what am I left with? I've got a pair of 0 there. I've got 1, 2, 3 positives. So 2 minus negative 1 is 3. And just like your teachers might have said in the past, anytime you're subtracting negatives, you can just change that sign to make it a big plus sign. So 2 minus negative 1 is the same thing as 2 plus 1. Or, so, you might have heard the old phrase, 2 wrongs don't make a right. Well, here, 2 negatives would make a positive. Okay, so let's show some of the following problems here. I use counting chips here. You could do the same thing with, you could say this is positives and this is negatives. So I've got 1 minus negative 3. So let me show 1 first of all. So here's a 0, here's a 0, here's a 0. And then I've got this 1 positive chip all by itself. So that's just positive 1. So I've started out with positive 1 right here. And then I'm going to take away, so this subtraction means take away, and I'll take away 3 negatives. So I'll take away 1, 2, 3 negatives. And then what am I left with? Well, just positives, and I end up with 4 of them. Okay, let's set up our problem 3b. So I need to start with 4 positive chips all by themselves. So there's 4 positive chips right here that are all by themselves, and then of course I've got some 0 pairs. So I've got 4. And then, I'm going to have to make some extra 0 pairs, so just bear with me here for a second. And like we talked about in class, it doesn't matter how many zeros I add. I could add 0 a million times, but as long as I'm adding 0, I'm not changing the value. So here, let's make sure I've got 4 positives. So there's my 4. Done with that. And now I want to take away negative 5. I want to take away 5 negative chips. So I'll take away 1, 2, 3, 4, and 5. And what am I left with? Well, I've got a 0 pair down here. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 altogether. And we can use our shortcut that you might have heard about in middle school, where you just take the, I'll do it in pink, your 2 negatives and make those a positive. And we can check that. 1 plus 3 is 4. And then if I make this a positive, 4 plus 5 is in fact 9. So both of these seem to work out. We're doing pretty good so far. And let's do some practice problems. So I've got 4 practice problems for us. We're going to solve by first just using that shortcut, changing the 2 negative signs to a positive. So our first step here, after we do the first step, we're left with 8 plus 6 and 10 plus 9, because these 2 negatives are sort of canceling each other out. The opposite of a negative is a positive. So the opposite of negative 9, or if I'm taking away negative 9, it's really like having 10 plus 9. So that's our step 1. And then for step 2, I'm just going to show 8 plus 6 is 14. And 10 plus 9 is 19. So let's take a second. If you need to, you can pause the video here and try these last 2 on your own. Otherwise, you can just let it play, and it'll be fine. So I'll try orange now. 13 minus negative 3. Your gut instinct tells you to make it just 10, but let's take our first step. 13, and I see these 2 minuses. I'll make those a plus. So 13 plus 3, and then here I've got 7 minus negative 24. Make that a 7 plus 24. And then I can solve. So 13 plus 3 is 16, and 7 plus 24 is 31. So I hope you guys are as pumped about this lesson as I am. I mean, like I said, I've been thinking about this day since March. Once I put the order in for those counting chips, I had exactly today in mind. And you know what? It didn't disappoint. I'm just as excited now as I was in March. So I hope you guys have a great rest of your day and come to class tomorrow ready to talk about subtracting negatives. We'll see you then.